Welcome back. Fix my hair a little bit. All right. So let's talk about forming Laurentia, or kind of completing the North American craton, or at least almost completing the North American craton. About 75% of it. So Laurentia, or that's kind of the name of the North American craton, forms the ancient core of what is now the North American continent. It consisted of the what's now the parts of the U.S., Canada, Greenland, parts of Scotland, and parts of Scandinavia as well. So talking like Scandinavia, like Finland, Sweden, those type of places. Many times in the past, Laurentia has been a separate continent, as it is now in the form of kind of North America. But also in the past, it has been connected to other continents, been part of a larger chunks of land called supercontinents. Which is interesting in itself because Laurentia consists of an assembly of network of different original cratons and these things called orogenic belts, these island arcs that got accreted, added on to the kind of perimeter of this formed original craton, kind of adding onto it. So small little microcontinents and oceanic islands kind of collided with and sutured onto the ever-growing Laurentia, and together formed the stable Precambrian craton that we see now today. Remember, we talked about greenstone belts last unit, but most greenstone belts formed during the Archean. They continue to form during the Proterozoic, but they were definitely nothing special, nothing to write home about. But they did differ in one important detail from the Archean to the Proterozoic, in that the absence of those ultramafic komatiites, which obviously resulted from Earth's decreasing amount of heat production. Remember, those komatiites are only able to be produced on Earth's surface if the interior of the Earth is much, much hotter, and that only happened when Earth was new, when there's a lot more radiogenic heat, a lot more radioactive material providing heat. So one big difference there. So we still get greenstone belts in the Proterozoic, but they're lacking those ultramafic igneous rocks. Excuse me. So in the early history of the Proterozoic of Laurentia, there's some important changes going on from about 2 billion to 1.8 billion years ago. Collisions among various plates formed several orogens. Orogens are linear or arcuate, arced shape deformation belts in which many of the rocks have been either metamorphosed or intruded by magma, thus forming plutons, especially batholiths. So we have this kind of core, but then we're going to start to add stuff to the exterior of it, the edges of it, these orogens. And again, in these orogens now, what's commonplace is metamorphosed rock. Talked about that a long time ago, metamorphic rocks, as well as rocks intruded by magma that would cool, thus forming large intrusive igneous bodies known as plutons, especially a pluton named a batholith. So these are all different intrusive plutonic formations. So a batholith is just a very large blob of most likely granite that cooled from granitic magma below the surface of the Earth. It's all the same stuff. It's all cooled magma. It's just what shape does it take on will determine the name of it. For instance, a stock is just a smaller batholith. A laccolith is kind of like a mushroom-shaped pluton. So depending on the shape of it, we can give them different names. So at the end of the Archean, this is kind of what we were dealing with. But by the end of the Proterozoic, this is kind of what we're dealing with. Kind of adding on a lot more things down here through this area. I shouldn't say the end of the Proterozoic. I should say the end of orogenic events in the Proterozoic, because we get some additional things happening towards the end of the Proterozoic that's going to add some additional land here and here. Again, the Archean cratons were sutured together kind of along these origins, thereby forming a larger mass, and we get these things being added on, adding on to what already existed. So remember, the larger Archean craton is made up of a bunch of the smaller ones that got sutured, kind of stitched together. So let's start back in time in the Proterozoic, and let's talk about the Paleoproterozoic, and we'll do that when we get back. So let's go ahead and pause here, and I'll see you back here in just a second, and let's start from the beginning of the Proterozoic, the Paleoproterozoic, the older part of the Proterozoic. We'll see you back here in just a second.